Let us continue to the next part. In this one, we will be looking at the challenges what we will be facing. In the last example, what we saw was basically based on simple alkanes. In other words, there were no functional groups present. For example, if we have any functional group present in the compound, or if more than one functional group is present, and how we will name them, which functional group will be named first, if polymers are present, how to name them, if there are many prefixes, if there is a stereoisomer, how to name them. We will see this. The solution is given here. The hydrocarbon will have an ending with ANE. Alkenes, that is a double bond compounds, end with ENE. Triple bonds will end with YNE. Oxygen derivatives like alcohols, aldehydes, ketone, carboxylic acid, etc. will have different endings, and nitrogen derivatives also will have different endings. Once we have learned the name of simple functional group, we need to find out the order in which they should be named. That is, the priority of the functional group should be the next thing we need to learn. The carboxylic acid gets the topmost priority, followed by acid derivatives, namely anhydride, esters, acid chlorides and carboxamides. It is followed by nitriles, aldehydes, ketones and alcohols, then thiols, amines, alkenes, alkynes and alkane. The least priority group is nitro. So you will be wondering how this priority is given. Is there any rule or is there any method by which we can remember that? The simplest thing is, some people say the highest oxidized state is the carboxylic acid, so it is given the topmost priority. And some other people say it is the alphabetical adder as it comes in the naming first, but we are not so sure which one is the correct one. Let us take these two examples. Before naming these compounds, we need to know few additional rules. So far we have only seen compounds with one functional group, but in the example given we had more than one functional group. So we need to know which functional group gets the priority and how the second functional group or the other functional groups are named. This table explains when many functional groups are present, what will be the main functional group and what is the ending, and if more than one functional group is present, how the other functional group will be named. Say for example, let us take the example of carboxylic acid. This always gets the top priority, so the main functional group is oic acid. If there are more than one carboxylic acid, one of the carboxylic acid will get the main functional group, that is oic acid, as an ending, and the other carboxylic acid will get the name carboxy. Now, if we take the first compound, we have the cyanide or the nitrile group, we have an aldehyde group, we have a ether, methoxy ether. So 1, 2, 3 functional groups are there. So how to name this compound? The topmost priority group is cyanide, so it can be called as the nitrile. It is followed by the aldehyde is the substituent, so it gets the name formyl. Then the ether is named as alkoxy. So the full name is 5-formyl 4-methoxy heptane nitrile. If you actually look at here, 1, 2, 3, 4, 5, 6, 7, the nitrile carbon is also included in the naming. You have to remember this. For the second compound, it has a ketone, it has a double bond, it is having a halogen, it is also having a aldehyde. So priority wise, aldehyde gets the priority, so the name is hexanal. Ketone is named as oxo, the olefin is given as E, and the halogen is chloro. So if we name, the starting lowest number rule says, let us start from this end. 1, 2, 3, 4, 5, 6. So 6 carbon unit, hexenal. In the 5th carbon we have the oxo group. In the 2nd carbon we have the chloro. So alphabetically chloro followed by oxo. So 2 chloro, 5 oxo, hexenal. And now let us see the rings. These are cyclic compounds. The simplest one is benzene. For the cyclic carbons, what we need to remember is what is the parent ring and what is its size. Then we have to see any functional group is present and is there any side chain, etc. we need to see. Let us take this compound. We have a cyclic system and a side chain. So these two are there. If you look at the cyclic structure, it is having 5 carbons. The side chain is having 6 carbon. So obviously, this ring is a cyclopentyl ring and the parent is the hexa 6 carbon unit. So this is a cyclopentyl substituted hexane. So one cyclopentyl hexane is its name. And if we take this compound, we have another cyclopentyl unit, but 1, 2, 3. 3 carbon propyl unit is the side chain. But you have to remember one thing, don't double count. When you are looking at the side chain, leave the carbon or the cyclic system's carbon should not be included in the naming. Okay, if we take this compound, there are 2 substituents are there in position 1 and 3. You can also interchange. It will still be 1 and 3 only. Both are methyl groups and the lowest sum, we don't have any other number. So the lowest sum is 1 plus 3, 4. So that means this compound can be named as 1,3-dimethyl cyclohexane. And let us look at this compound. We have various possibilities here. So we have different types, we can number them 1, 2, 4. So in this case, if we number this as 1, 2, 4, the total number is 7. So the lowest possible sum is 1 plus 2 plus 4 equal to 7. And for this compound, we have to say this as a 1, 2, 4 trimethyl cyclohexane. If you start from here, it is going to be 1, 2, 3 and 4. So that number will be 1 plus 3 plus 4. So 4 plus 3, 7 plus 1, 8. So that is not the lowest number. Or if you start from here, number 1, 1, 2, 3, 4, 5. So this will become 1, 2, 5. So 5 plus 2, 7 plus 1, 8. So that is also the wrong number. If you start from here, 1, 2, 3, 4, 5, 6. Then this becomes 6, 4 and 1. 6 plus 4, 10 plus 1, 11. So that is also the highest number. So that is also the wrong one. So we have to always look for what is the lowest sum. So here the lowest sum is going from the anti-clockwise direction 1, 2 and 4. If we take this compound, we have 2 substituents. One is a 1, 2, 2 carbon unit, that is the ethyl unit. Another one is 1, 2, 3 propyl unit. So we have 2 substituents are there. Ethyl gets the, in alphabetical order, ethyl gets the first priority followed by propyl. So this compound is named as 1-ethyl 3-isopropyl cyclopentane. And if you look at cis and trans isomers, this is a cis isomer, this is a trans isomer. Both the methyl groups are opposite to each other. In this one, both the groups are in the same position. So whenever you are naming olefins, you have to remember one thing very carefully. You have to walk over the bridge. Remember, walk over the bridge. What is that bridge? The double bond is the bridge. So you have to always walk over the bridge to name the alkenes or alkynes. And if you take the cyclic system, we have cis and trans. Cis means both pointing towards the same side. Trans means one pointing to the upside and the other one pointing towards the downside. Then finally, if we look at biomolecules, the priority is little bit different than the organic compounds. In biomolecules, thiols or the sulfur derivatives gets the highest priority, followed by, this is the ethers, thioethers, followed by thiols, then alkyl. So if you look at the groups S, O, N, C. So that is the order it is actually coming. Then this is the overall nomenclature for many heterocycles. We will study more details about the heterocycles nomenclature in heterocyclics chapter.